All right, a little Unit 9 test review. So just want to start by looking at the differences between these equations and finding h and k. So you have to remember that in basically any function equation, we have h is with the x, and then k is at the end. So in the first one, we have an h of -1, but then we have nothing at the end, so it'd be -1, 0. Versus the second one without the parentheses, that one, the shift would be 0, 1. The 1 is on the outside. So that's our k. And then this last one would be a +2, -1 for our hk. So just worth mentioning. All right, so let's practice graphing an exponential problem. So our general form is a times b to the x minus h plus k. So we can identify our shift first from these two values, which would be +1, -2. So if we shift our graph over +1, down -2. The next thing I'm going to do is make a table. I might not have enough room here, but I'm going to scoot it over a little bit. And then my a is 4, so I'm going to take 4y. And my base is 1/2, so in the middle I'm going to take it 1/2 to the power of my x's. And I'm going to plug in -2, -1, 0, 1, 2. So 1/2 to the -2 power would be 2 over 1 to the +2, so it'd be 4. 1/2 to the -1 power, you'd reverse it, 2 over 1 to the +1 power, so 2. Anything to the 0 power is 1. 1/2 to the first is 1/2. 1/2 squared is 1/4. Then multiplying that middle column times 4, I'd get 16, 8, 4. 4 times 1/2 is 2. 4 times 1/4 is 1. And then we're going to graph the first and last column from my shifted point right here. So -2, 16 is a little bit off my graph. This is exponential decay, so it's going to come down. -1, 8, 0, 4, each point going from my shift, 1, 2, and 2, 1. And it's going to start up here and come down. It's going to get infinitely close to that y equals -2 line, but it's never going to cross. And that line is called your asymptote. So y equals -2 is your asymptote. In exponential growth and decay, the domain is all real numbers because you can plug in any x. The function can take any value of x. And then the range, it only outputs values that are greater than that -2 value. So the range is all y's that are greater than -2. Okay, graphing a log function is going to be similar. So first identifying the shift, which would be -1, -4. So shifting the graph to the left 1 and then down 4. And then I'm going to rewrite it in exponential form. So it's going to be 3 to the y power equals x, because I've already graphed the shift, so I can just focus on this part right here. So now I'm going to make my table again. Actually, don't need 3 columns because there's no a. A is 1 here, so we're not going to use that third column. The only difference here, well, not the only difference, but a main difference is that we're plugging in y's into this function. So I'm going to plug in y's this time. And then it's going to be 3 to the y power for this column. So to do 3 to the -2 power is going to be 1 over 3 squared, so 1/9. 3 to the -1 power would be 1 over 3 to the first, so 1/3. 3 to the 0 is 1, 3 to the first is 3, 3 squared is 9. So then graphing again from my shift, you would go over 1/9 and down -2, over 1/3 down -1, 1, 0, 3, 1, and then 9, 2. And then that log function is going to look similar to this. So this log is base 3, so it's the inverse of an exponential growth function. So the growth function would look like this, and then that inverse is reflected over this line y equals x. So that's why it's turned and looks like this. And so it's a good way to check to make sure your graph is correct. In a log function, our domain is restricted, and our domains are restricted here because you wouldn't take anything 3 to what power equals x. You're going to get nothing less than -1. So all your domain is going to be x is greater than -1. And then your range is all real numbers because we're going to continue infinitely in the y direction this way, and then we're going to continue slowly to get infinitely bigger this way. So the range are all the y values, so all real numbers. And then the asymptote is that horizontal line or vertical line right here, x equals -1, based on my shift. All right, just evaluating. Give exact answers and simplify. So this would be 9 to what power equals 1 over 81. Since I have a whole number and it's taken to an exponent equals a fraction, that means that this has to be negative, and 9 squared is 81, so it'd be -2. So 9 to the -2 power would be 1 over 9 squared. So that would give me the 1 over 81. So -2. 5 squared is 25, so 2 for this one. This one would be 27 to what power equals 3. So since I am going from a large base to a smaller value, it's going to be a root. Remember, you can always factor tree this and see how many 3's does it take to make 27. It takes 3. So since 3 cubed is 27, the cubed root of 27 is 3, which means that's the same thing as 27 to the 1/3 power. So it would be 1/3. I'm going to rewrite this first and have a positive exponent. So move this to our numerator and make it e to the positive 7. And then I have base e for ln. So really this cancels here and we just get 7. Another way to look at it though is to rewrite it in exponential. It'd be e to what power equals e to the 7th. And then you can see that it's x equals 7. So 7. All right, solving. So in this one, I'm going to rewrite it. It'd be x squared equals 81, and then I can solve the square root, and I'm going to get x equals plus or minus 9, but I can't have a base of a -9, so it's going to be x equals positive 9 is my only answer. Here the bases are the same, so you can set the exponents equal. So 3x plus 1 equals -2x. So I'm going to subtract 3x from both sides. I'm going to get 1 equals -5x. Divide by -5. I'm going to get x equals -1/5. Let's see, did I do that correctly? Let's plug it back in. Be 6 to the -2 times -1/5 would be +2/5. Over here I'd have 3 times 1/5 would be -3/5 plus 1 would be 5/5, so it'd be 6 to 2/5 again. So it does work. X is -1/5. All right. In this one, you could exponentiate each side, so take it to the 9th power on each side, and we'd get, this would cancel, 3 equals 9 to the x. Or you could rewrite it using your log rule, so 9 to the x power equals 3. But then you have to take the log of both sides, so log of this side and log of this side. So then the exponent comes out front. So it'd be x times the log of 9 equals the log of 3. And then divide both sides by the log of 9. So you get x equals log of 3 divided by the log of 9. And you could plug that into your calculator to get a decimal approximation if I asked for it. You could also use the change of base formula. So remember that formula says it's the log of 3 over the log of 9, which is what we got. In this one, I know that 125 is the same thing as 5 to the third power. If I rewrite that as 5 to the third, now my bases are the same, so I can set my exponents equal. So then I get 2x minus 1 equals 3, and then solve for x using my algebra skills. Add 1, divide by 2, I get x equals 2. Plug it back in, I get 5 to the third equals 5 to the third, so we're good there. Okay, and this one is a log, so I'm going to exponentiate each side, but I have to get this part by itself first. So the first thing I'll need to do is add 5, get 3 log base 2 of x equals 12. Then you'll have to divide by 3, log base 2 of x equals 4.
Please pardon the interruption.
Then rewrite it.
The main office immediately. Once again, Nevada Pendleton, please report to the office immediately.
2 to the 4th equals x. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So x equals 16. If I plug that back in, we're okay. We can have log of 16. We just can't have log of a negative number. A couple more solving. So I have to get this e to the x by itself. 5e to the x equals 15. Divide by 5. E to the x equals 3. If e to the x equals 3, I can take the ln of both sides. And then that comes out front. So x times the ln of e equals the ln of 3. Now the ln of e equals 1 because it's base e of e. So x equals the ln of 3. And you could type that in to get an approximation if necessary. But that's the exact answer. Okay, so over here I'm going to start by adding 5 to get this part isolated. So then I get 9 equals 2x plus 3. Since I can't change 9 into a base 2, I'm going to have to take the log of both sides. So log and log. So then I'm going to get log of 9 equals, and this whole exponent will come out in front. So it'll be x plus 3 times the log of 2. So to get the x by itself, the first thing I'm going to do is divide by the log of 2. So then I get log of 9 over log of 2 equals x plus 3. Then to get x by itself, I would subtract 3. So the exact answer here is going to be log of 9 divided by log of 2 minus 3 equals x. If I wanted an approximation for that, you would have to put in the log of 9, and then that divided by the log of 2, get that answer, and then subtract 3 from it. So x is approximately 0.17 if we round to the hundredths place. But this is my exact answer. So that one was a little trickier. All right, writing exponential functions in this form. So we're going to start with a system of equations. We have 2 points, xy and xy. So first I have 2 equals ab to the second power. And then I have 18 equals ab to the fourth. Whatever side has the smallest b, I'm going to solve that one for a. So that'd be the left side here. So I'm going to solve for a by dividing by b squared. So I get a equals 2 over b squared. Then I'm going to take that and I'm going to plug it into the a over here. So that'll look like this. 18 equals 2 over b squared times b to the fourth. Now that's b to the fourth over 1. So now I can reduce b to the fourth over b squared, and that reduces to just b squared. You subtract exponents when you're dividing. So then I get 18 equals 2b squared. Finish solving for b by dividing by 2. 9 equals b squared. Take the square root. Technically, you get plus or minus. We're going to just focus on the positive one since it's a base, and we want our base to be positive. That's part of my answer. Plug it back in. A equals 2 over 3 squared. A equals 2/9. Don't forget to write the final answer now. It's AB to the x, so y equals 2/9 times 3 to the x power would be your final answer. I don't know how long this video is getting, so let's see. This would be same thing, 6 equals AB to the second, and 48 equals AB to the fourth. And then you would solve for A, and then plug that back in over here, solve for B, and plug that back in over here, and then write your answer. Okay, find the inverse. So for the inverse functions, we're going to switch x and y. And then we're going to rewrite it in exponential form. And then if necessary, solve for y. So we're going to have x equals log base 6 of 4y plus 4. This is in parentheses, so it stays together. And then we're going to rewrite it, so it'll be 6 to the x power equals 4y plus 4. So then solve for y, so subtract 4, be 6 to the x minus 4 equals 4y. Then I'll have to divide by 4. So my final answer here is going to be 6 to the x minus 4 over 4. I actually can't simplify that, even though they're all even, because 6 to the x has an exponent, so it's not a whole number, so you can't simplify by 2. So that's our final answer there. It could be rewritten as 1/4 times 6 to the x minus 4 if you wanted to rewrite it like that. Then this is your a value, this is your k value, and h is 0. So exponential function with a shift of 0, -4, and an a value of 1/4, which might look a little bit more familiar. Okay, rewrite as a log function. So remember, log, it's the same base, so this would be base 6, and then the output becomes the input, and then the exponent becomes the answer. And then you can always check 6 squared is 36. Rewrite as exponential, it'd be 3 to the 4th power equals 81. So knowing how to rewrite it. Okay, I'm just going to set these up, and then hopefully you can find the answers. So you deposit $1,200 into the account, so that's going to be our starting value, our P or our A, I guess, depending on what we're looking at here. 6% interest, that's going to be our R. We're going to plug that in as 0.06. Compounded continuously, we need to use A equals P times E to the RT, or PERT, and 5 years would be our T. So we're going to plug that in as 1,200 times E to the 0.06 times 5. So I would do the exponent first, 0.06 times 5, and then from there you should be able to plug it all into your calculator. So then 1,200, oh goodness, times, each calculator is different, so hopefully you know how to work your calculator specifically. So $1,619.83 after 5 years. 800 in an account earning 4% interest, 5 years compounded monthly. That means that n equals 12. and then this would be P, R would be 0.04, T would be 5. Since it says compounded monthly, it's interest, so we're using this formula, which is 1 plus R over N to the NT right here. So it'd be 800, and then 1 plus 0.04 divided by 12, and then to the 12 times 5 power. Really, the first thing you should do is do 12 times 5, which is 60, I think. And then 1 plus 0.04 over 12 to the 60th power. Once you evaluate that exponent, you can put everything in your calculator now, because your calculator will know to do the parentheses first, and inside the parentheses, it will know to do the division before the addition, so it's covered. And then it will exponentiate before it multiplies by 800. So, okay, I must have entered something wrong because I got a very large number. Okay, I think I did plus here instead of divided by. There we go. So $976.80. Value of a new car purchased for this much decreases. So we're still dealing with money, but it's not interest. And so we're using exponential decay, which is A 1 minus R to the T. So this one is the original value would be our A, 31,500. 10.5%, moving the decimal back 2 places or dividing 10.5 by 100 would give me the decimal of 0.105. So that's what I'm plugging in for R. So 1 minus 0.105, and then after 4 years. And you should be able to plug that in exactly like you see it. So 31,500, parenthesis, 1 minus 0.105 to the 4th power. The value should go down. It is decreasing by 10% per year. So it's not surprising that the value has lost over $10,000. And the last one. Increasing, tiny towns population is increasing, so there's no interest involved here again, so we're using exponential growth, which is the same as the last one, but plus R to the T. So it's 12,000, 1 plus 4%, and then 8 years. And then plugging that in. And then based on the context of the problem here, you're going to want to round to the nearest person because we're talking about population. So it'd be 1,600 or 16,423 people. Okay, just in time.